So this is a fourth in a series of screencasts on the topic of air pollution. And the next topic within air pollution that we're going to look at is acid deposition. So again, before we dive into these slides, I am showing the process of acid deposition, but that's just to give you a deeper understanding of it. I want you to focus on the sources of acid deposition pollutants and also the effect on human health and the environment, or human, not really health, but human conditions and the environment. So first of all, the definition of acid deposition. It's when nitrogen oxides and sulfur oxides are released into the atmosphere and they combine with atmospheric oxygen and water to produce a secondary pollutant called nitric acid and sulfuric acid. These secondary pollutants further break down into substances known as nitrates and sulfates, and that's the acid part of the acid deposition. So we'll take a look again at the primary pollutants, sulfur dioxide and both of the nitrogen oxides. These are combining in the air with water and oxygen that's in the atmosphere and producing sulfuric acid and nitric acid. As you can imagine, those also are acidic compounds. The sulfuric acid and the nitric acid break down such that the hydrogen atoms are dissociated from the sulfur oxides, and that produces a material, in this case a sulfate, which is very acidic, and in this case a nitrate, which is very acidic. And it comes down in the form typically of rain, but it can also be snow, which once the snow melts, then it's acidic to the surface. So again, we want to focus on what impact this has. So here are some of the effects of acid deposition. First of all, it lowers the pH of lake water. That makes it more acidic. That's harmful to species that live particularly in water ecosystems, aquatic ecosystems. A number of fish are very sensitive to pH and can't survive in pHs, say below 5.5. It can also affect plants that live in aquatic ecosystems, and it can affect the food web or food chain, if you will, within that ecosystem. The next major effect of acid deposition is it mobilizes metals found in soils and releases these into surface waters. So the metals of particular concern are aluminum and mercury, as we mentioned before. Those naturally exist in soils, but when acid rain falls on these soils, it releases them from the soil and then they get into surface waters, which is dangerous again to the species that live in those ecosystems. A fourth effect of acid deposition is that it damages statues, monuments, and buildings and other structures. So humans, and even your car finishes, humans have things like marble statues in ancient Greece or some of the limestone buildings that make up Washington, D.C., and acid rain actually causes those human-made materials to be degraded significantly. So of note here is that acid deposition doesn't directly harm human health. So it's not like acids on our skin will make our skin dissolve. That we're not affected, or even our breathing is not affected by acid deposition. But some of the precursors to acid deposition do harm us, so they're also of concern for those reasons. So next we're going to take a look at a few slides to look at ways to reduce some of these air pollutants. And the focus is mainly on removing some of the sulfur and some of the nitrogen that would get into the atmosphere and cause problems. So air pollution had already happened in the United States as a result of the Industrial Revolution, and then it happened overseas in places like China and India now, where they're going through great periods of air pollution. But the best way to reduce air pollution is to prevent it from prevent those pollutants from getting into the atmosphere in the first place. But once we've already got these in the atmosphere, we can implement some exciting technology, and actually some very simple technology, to reduce the amount of future air pollutants getting into the atmosphere. So the first one here is removing sulfur dioxide from coal by fluidized bed combustion. So that's a very fancy term in burning coal next to some material called calcium carbonate. Calcium carbonate is a very inert type chemical. It's not harmful at all, and very fortunately it absorbs things, pollutants from burning of coal. And not only that, very conveniently, when it does this, it forms a material that can be used to make sheetrock. So you get a double benefit there. You can reduce the amount of sulfur dioxide being released into the atmosphere from the burning of coal, and you can actually get a reasonably important product called sheetrock, which is used to construct rooms in homes. Okay, a second interesting way to reduce air pollution are by having catalytic converters on cars. So catalytic converters are materials that are made from usually platinum and palladium, various metals, which help to screen out or prevent some of the emissions from the car from getting into the atmosphere. And actually, I just learned recently, when I had a problem with getting my car tested annually for its emissions test, and it failed because one of the catalytic converters failed. And it turns out there are 4 of them on my car, which I thought was interesting. I always thought there was just one catalytic converter per car. And here in the United States, we have relatively strict regulations on the catalytic converters and how much pollutant can get into the atmosphere. It's not as strict in some places that are still working on that, like Europe. But catalytic converters have proved to be very useful. A third technology to reduce air pollution are scrubbers on smokestacks. That's not shown on this slide. It will be on the next slide. The fourth technology are baghouse filters. And this diagram on the bottom left shows you a baghouse filter. So air that's dirty is brought in through this unit, and it goes through a series of filters. Filters are things like a coffee filter. It holds some materials in while letting other materials out. So in the case of a coffee filter, it keeps the coffee grinds in and lets the water, which is a smaller molecule, pass through. So in these baghouse filters, there is a bag, something like a vacuum cleaner bag, that retains the pollutants, which are larger in size than the air molecules. And so then the air molecules are allowed to pass through, and the trapped particles are eventually cleaned and moved out of the unit, and they dislodge the trapped particles and then reuse the baghouse filter. So that's a very common technique. And the last technique here is electrostatic precipitators. And again, it sounds a little fancier than it really is. So dirty air containing pollutants is moved in, and it goes across an electrode, which is something that is negatively charged. And the dirty air pollutants pick up this negative charge. So they now have a negative charge attached to a particular pollutant. The air continues on and then goes through a series of positive electrodes. And as it goes through, the pollutants are picked up by the positive electrodes and retained there. And clean air, which is not charged, continues to pass through. And then at the end, once the air is stopped from running through and these positive electrodes are treated with a negative electrode, which makes them drop all of their pollutants that have been charged, and they can collect them and again remove them. All right, now we'll go on to the next slide to look at scrubbers on smokestacks. Okay, in a scrubber, the dirty air, the polluted air, is brought in through the bottom of the scrubber, and the air would rise, but it would have to go through a set of very fine water mist particles. And the water actually collects the pollutants. The pollutants are attracted to the water, and the air molecules continue on and are not attracted to the water. So eventually you get a collection of sludge, or the contaminated material that's been collected by the water. And the sludge can be removed, and the scrubbing water can be reintroduced into the system, so it just moves in a cycle and you don't even need to waste water. So a couple of points to be made about these technologies. First of all, prevention is better than having to apply one of these technologies. So people have been able to create or find fuel that has fewer impurities. One is what they call clean coal. It's not really clean, but it's cleaner. It's lower in sulfur, and that sometimes is found naturally, and sometimes they process the coal in a way to remove the sulfur, so applying a technology. And then when that coal is burned, less of the impurities get into the air. But the thing to make no mistake of is that it's still not really clean, it's just cleaner. Other ways to prevent air pollution is to increase efficiency of operating systems and increase conservation. In other words, use less fuel by using a more fuel-efficient vehicle. And lastly, use alternative energy sources, of course. Okay, the other final comment is to remember that those technologies do produce cleaner air, but it's not entirely clean. Okay, so next we're going to turn attention to stratospheric ozone. And again, I'm going to run through the whole process of ozone creation and ozone destruction, rather. And what I want you to focus on, though, is the source of ozone destruction and the consequences. Okay, so let's return to an earlier diagram from Chapter 4 of your textbook, which shows Earth's atmosphere. So you may recall the lowermost portion of the atmosphere in miles, from 0 to 10 miles, it's 0 to 20 in kilometers, is the troposphere. And that's where all of our weather occurs. It's where molecules are present in large concentrations, particularly nitrogen and oxygen. And it's where all the air that we breathe exists, and where most of the pollutants that we have would also be existing. The next layer above that is called the stratosphere. It runs from 20 to a little bit over 60 kilometers, so that means it runs from 10 miles to about 31 miles above the Earth. And the stratosphere has far fewer gas molecules because they're not pulled by gravity to the Earth. And the most important part to living things is the bottom part of the stratosphere, which is the peak ozone layer. So the peak ozone layer is a layer where there are a number of O3, or ozone molecules, that are in concentrations high enough to absorb UV radiation so that it doesn't reach organisms that live on the Earth and damage, damage their cells. So to repeat and emphasize some vocabulary terms you do need to know, stratospheric ozone provides protection from ultraviolet radiation, and the molecule is O3. So this screencast is now short on time, so I will cover the anthropogenic sources of ozone destruction and also the consequences in the next series.